Okay, so for this video, we're going to see how those angle pairs we identified last time are going to relate to each other, supposing that the lines being cut by your transversal are actually parallel. So in this diagram here, I have two lines, A and B, and I can tell that they're parallel because of these little arrows here. And my transversal is C. So I've got a bunch of angle pairs, like 4 and 5 are alternate interior, 4 and 8 are corresponding, 6 and 4 are consecutive interior, all of those different angle pairs. So to start things off, we have a postulate. So this is something that we're just going to believe as true. It says if lines are parallel, then corresponding angles are congruent. Okay, so this is kind of where we're going to start everything off and base everything from. So based on this picture here, since A and B are parallel, we can make the conclusion that 2 and 5 are congruent, 3 and 7 are congruent, 4 and 8 are congruent, and 6 and 1 are congruent. This is a postulate. I'll just go ahead and say POST for postulate. Now we have 3 following theorems, and those theorems are only true based on this one postulate, meaning we use this postulate to prove them, which we will prove together in class. So they have the same hypothesis. We always need to have parallel lines. So you're not going to use these theorems or this one postulate if you do not have parallel lines. So I'm just going to put some quotes here. So if lines parallel, then also alternate interior angles are congruent. So not only are your corresponding pairs congruent, but also like 3 and 6 and 4 and 5. Those angles are congruent. This is a theorem that we can prove using this postulate. Likewise, if you have parallel lines, then your alternate exterior angles are congruent. That's another theorem we will prove in class. So we could say, based on this picture, like 2 and 8 are congruent, 1 and 7 are congruent. And then the last theorem has to do with your consecutive interior. So supposing you have parallel lines, your consecutive interior angles, you might guess congruent, but actually these are supplementary. And that is, again, a theorem. So we've got 4 big ideas here. First one is a postulate, and they all rely on the same hypothesis. If you do not have parallel lines, you're not going to assume any of these conclusions. So since these lines are parallel, 2 and 5 congruent, 3 and 7 congruent, 4 and 8 congruent, 1 and 6 congruent, that's our corresponding angles postulate. And alternate interior angles congruent, alternate exterior angles congruent, and then that consecutive interior, those are always going to be supplementary. So that's just kind of the oddball there. As I mentioned, we are going to go through and prove these next class. Whenever we use these in a proof, we're actually not going to use any names of them. We're going to abbreviate. So those abbreviations might look something like if parallel, corresponding angles congruent. And we want to word it like that. That's the least, or I should say, the most abbreviated form that we're going to have. We're not just going to say corresponding angles postulate, because there is actually another one that we're going to see later on. Also, we want to get in the habit of kind of quoting what a theorem or postulate says. That way, it helps us remember really what it's talking about. If we just say the name, it's least, or I should say, we're less likely to remember really what that thing is referring to. So that should give you more than enough information to get a head start on 3.2.